I've lived in this area within a couple miles most of my life. I've lived a little farther away a few times. And so we started farming this in '75. The average around here was probably 60, 70 bushel per acre. It's good productive soil.
Things are changing for farmers like Bill in Elgin, Iowa. Heavy rains and flash floods, coupled with challenging periods of droughts, have caused land damage and unpredictability for landowners across the state.
You know, we just came through, three of probably some of our most challenging years as far as weather goes. 2012 being a drought, and then, last year and this year, the springs have been just atrocious, where the rainfalls come and they don't seem to come in that inch rainfall anymore. It's more, 5-6 inches at one time.
While it can be difficult to control these conditions, Iowa scientists are helping farmers, community leaders, and the general public better prepare themselves for pending disasters. The Iowa Flood Center, in partnership with the Iowa DNR, has installed more than 200 stream stage sensors on Iowa bridges since 2011. The IFC has also developed hydrologic models that help landowners understand how mitigation projects can reduce flood damage in Iowa watersheds. The Flood Center has produced flood inundation maps for 13 Iowa communities. These maps allow community members to view the possible flood inundation based on forecasted river levels. The Flood Center has ongoing partnership with the National Weather Service, the National Science Foundation, and NASA. These partnerships allow for hands-on training and research experience for graduate and undergraduate students at the University of Iowa. Now, scientists and researchers at the Iowa Flood Center, based at the University of Iowa, are designing a system to help communities and landowners prepare for floods with even more speed and accuracy by measuring rain and soil moisture with groundbreaking technology.
Runoff from rainfall goes into rainfall or flood forecasting models, and the better rainfall estimates we have, the better flood prediction we can make.
We were looking for ways of transmitting data in real time to our computers, and some 20 years ago we learned that actually that's not so easy. There are no off-the-shelf solutions that would be inexpensive that a research group at the university could afford. So we have to invent it ourselves.
The Iowa Flood Center began developing a network of rain gauges near Iowa City in the late 1990s. The network was designed to help researchers at the University of Iowa improve our ability to understand and forecast flood events.
Rainfall is the main agent of flooding, heavy rainfall in particular, and so it is very important that this information is accurate.
Not only did this network look to provide on-the-ground data to compare with satellite observations, it was also designed to examine the variation of rainfall over distance and time.
Typically, rain gauge networks in this country, they are 20, 50 miles apart, and rainfall varies at spatial scales that are much shorter than this. We wanted to know what is that scale of variability of rainfall at much shorter distances and over shorter durations.
The IFC design calls for a two-bucket system. If there is a major discrepancy between two gauges at the same site, the researchers can investigate that cause for the discrepancy. The influence of this innovative idea extends beyond the state.
We promoted this approach, and now there are several networks around the world that deploy this dual gauge arrangement.
In addition to rainfall, each site collects real-time soil data, including water content in the soil, which can be a significant factor during flood events.
This is very important because it helps to partition the rainfall into how much water infiltrates into the soil and how much water runs off.
All data from the rain gauges is available in real time through the Iowa Flood Information System, an interactive website developed by the Iowa Flood Center.
The data is available in real time at no cost. Anybody with a web browser can just go there and look at the data. There are several other rain gauges across the country, but they don't operate like this.
Not only can Iowa Flood Center technology save researchers time and money, it allows them to be more accurate when compiling data.
We always have a backup. When the gauges agree, we're happy. When they don't agree, we have enough information to figure out what was going on.
Despite these improvements, Iowa still lags behind in drought and flood prediction capabilities. Once implemented in more locations, this new technology could dramatically improve Iowans' ability to understand and prepare for changing weather conditions.
We would definitely like to expand to the whole state.
We really would like to have a uniform quality of the data over the entire state. Our interest as the Iowa Flood Center is in the entire state.
In addition to landowners, a statewide rain and soil moisture gauge system could have significant benefit for municipalities and managers of local watershed groups. Laura Friest and the Northeast Iowa Resource Conservation are working closely with communities in the Turkey River watershed.
What we found is it's not just the producers, but also the county engineers and emergency management personnel, county boards of supervisors. They're all talking about, well, did you watch it? Have you seen it? Did you see what happened during the last storm event? And seeing how that translates to what happens in the river, and they really own it.
This communication allows community leaders and residents to better prepare for disaster and mitigate the effects that extreme weather conditions can have on bridges, roads, and other infrastructure.
Our rivers flood. Our large rivers flood over and over and over. We have damage to the communities. We have millions of dollars in damage to road and bridge infrastructure. And what do? We put up higher sandbags, higher levees. We don't actually address it. The more people that understand the hydrologic system, the better. So looking at it from the field level where the producer is watching it and he's seeing the soil moisture change and how rainfall then hits that, oh, my soil moisture is high. I know I'm going to have runoff. This is what's happening. He can understand it. We're also monitoring at tile lines so they can see nutrients leaving their fields. They can try to reduce that. And then you go downstream and there's a gauging station and they see it move through the system. It all becomes very real.
These very real situations emphasize the need for a statewide flood sensor network. While the issues facing communities in regard to flooding can be difficult to deal with, technological innovation is an important step in finding a solution.
Can we solve flooding? Can we improve water quality? Absolutely. If we don't have the tools to do it, we will flounder. We will be inaccurate. We will make huge mistakes. The more accurate we can be, the better we can understand the system, the better everyone can understand the system, from the producer, the community, all the way up the line, the more likely we will be able to succeed.